and so if you remember, this was the last problem in the previous lecture, and we were supposed to calculate the rotational velocity. Yeah, so we worked out the rotational velocity, and the main trick here was that because there are two types of motions, this motion as well as this motion as a whole. So this is only possible if the velocity at the top is 2 times this velocity, which is 30 miles per hour. Yeah, and because this moves with respect to this, and there is no slippage here, there is no sliding, so the velocity here will be 0. And we worked that out. Of course, you know the radius, and when you know the radius, you can use that formula r times omega. The next question, the next problem at point 2 is actually related to this, and this time you change some assumptions. So it's the same problem, but this time you assume that you are sitting on ice, and there is only spinning with the same rotational velocity. So the spinning motion is there. So if I think about this again, this velocity is 0. So there is no translational motion, only spinning, not translating forward. Determine the velocities of points at the top. So you are supposed to calculate this velocity, and at the bottom, and this velocity. Because the rotation is in this sense, so this velocity must be. Now this velocity cannot be 0. Okay. Why? Because you can go back to that, and basically when you stop, because it's a rigid body, so if one point stops moving in a certain direction, every other point must stop moving. So if you set this velocity to 0, you have to subtract it from this point, you have to subtract that from the velocity of that point, and you have to subtract that from the velocity of this point. So remember, so if this was v, now and if this was 2v, and if this was 0, now you have to subtract v from this, and v from this. Okay, so now the new velocities are, this must be minus v, so that's why I indicated the arrow. Yeah, because the arrow indicates that, so this will be your minus v. Actually, now I can call it v. This will be 0. Yeah, and that will be 2v minus v is v. Yeah, so that's, and also identify the directions of these velocities. So of course this is forward, this is backward, and this is 0 as per assumption. So it was only a conceptual question. The next question looks scary, but I think it's, if you know the link between rotation and translation, this should also be very easy. So let's start with the statement. The disk in a computer hard drive spins at 7200 RPM. Yeah, so you have this 7200 RPM. The sense is also given, it's anti-clockwise. Now at the radius of 30 millimeter, yeah, so of course this will have a large radius, but you are considering a circle and on the hard disk which is 30 millimeter from the center. Yeah, so that's why you say at the radius of 30 millimeter. A stream of data is magnetically written on the disk. Okay, so writing is going on with some mechanism, and this is a zoomed version, and the spacing between data bits is 25 micrometer. Okay, so if you zoom in here on this circle, you see that between any two bits the distance is 25 micrometer. Okay, so this is important to convert between bits and distance. अब पता होगा कि अगर आपने 10 बिट्स राइट किए हैं तो उनमें कितना डिस्टेंस जो है ना along this circumference जो है ना cover किया होगा. Now you want to know, determine the number of bits per second that pass by the read-write head. Okay. So you want to know the number of bits per second. Okay. So we can start with the angular velocity. The angular velocity is 7200 RPM, and you will multiply this, yeah, with something so that the result is in radian per second. Yeah, and that's something, you know, that you have to get rid of the revolution, you have to get rid of the minutes. That is something we have been doing many times. Okay, but this omega will not help us because this conversion is in terms of distance. Yeah, so first we need to convert this omega into some kind of distance. So you know that the velocity, the linear velocity, will be important for us, because linear velocity is the distance traveled along the circumference. So this will be r times omega. Now the circle of interest and for this question is this one, not the overall circle. So we are only considering this circle for which the radius is 30 millimeter. So I multiply 30 millimeter with that answer I get from the above line, which is radian per second. So now I have something, because this is millimeter, so I will have to multiply this again by some factors so that my overall answer is in meters per second. Meters per second. And maybe if I'm clever, I can do something else. Yeah, because I know this conversion is given in micrometers. Yeah. This is given in micrometers. Maybe the proper unit for me is not meters per second, but micrometers per second. So maybe if I multiply this by a factor above and below so that I get something, I'm just writing it down. So I will have to get something in micrometers per second. That will be better, because it will be easy to link it to that. Now the $1,000,000 question, the number of bits per second. So now I say, I'm just writing the shorthand, number of bits per second. I want this. Okay, so I know that that will be the number of bits. I can say the number of bits per second. I can write it in this way, number of bits per micrometer. Micrometers में कितने हैं terms? I can just try the number of micrometers. Okay, because this is not just a unit. I'm talking about the number of micrometers. So this is a distance, and I can say the number of micrometers per second. Per second. Yes. Now this number of micrometers per second is this velocity. Okay, so this number will come here, and this number of bits per micrometer, you already know it. Okay, this is this 25. Let me just simplify this because this can confuse you. This 25, you have 25 micrometers. It is for 1 bit. Yeah, so now you can say that for this number you have to write 1 bit per 25 micrometer. The 25 micrometer must be in the denominator. Okay, because I'm starting from number of bits per second, So I apply chain rule, number of bits per distance multiplied by distance per unit time. So number of bits per distance is this, 1 bit divided by 25 micrometer. You cannot say 25 micrometer per bit, yeah, because that will be the reciprocal. And I just multiply this with this answer, yeah, which is micrometer per second. So you see the trick is this micrometer will cancel out with that micrometer and you will get your answer in 1 bit per second. So is this clear now? It looks tricky, but if you are careful with this piece of information and if you know whether you divide or multiply, it should be very easy. Okay, let's move on. इसमें कोई क्वेश्चन है तो बता दें अभी. Okay, the next question. We have a spur gear set, simplest set of gears that has been designed with the following specifications. So, okay, you have a pinion gear and you have an output gear. So on the pinion gear, the number of teeth is 32. Okay, so this is your NG. No, NP, sorry, NP. P is for pinion. And this is the diameter, which is DP. Now output gear, so this is NG because you write G for output gear, and this is DG. Determine whether the gear set will operate smoothly. Remember, we had a requirement that when two gears mesh with each other, they can only operate smoothly if they both have the same proximity. Same proximity means that the density of teeth per unit distance must be the same, and for that we use a quantity which is called the diametral pitch, if you remember, diametral pitch, P. So we have to know this P should not be confused with that P because this P is for pinion. That's why we have to write it straight, and this P is actually italic. This is for the pitch. So I will say P. Okay. Let me write this italic. Why cannot? Why? Yeah, italic. Okay. So P for the pinion must equal P for the gears if we want smooth operation, because only then they will have the same number of teeth per unit distance and there would be no actually noise, no problematic, no incompatibility. So we need to check this. So P, but we also know that the formula for that diametral pitch for any gear, whether it's pinion and output, is just the number of teeth on the gear divided by the diameter. You also see 2R. Okay, so now we have to find out this value for the pinion gear. So it will be NPD divided by DP. So that is 32 divided by 3.2 inch. Yeah. So you will get this, I think, is 10. This is 10 teeth per inch. And let's calculate the same ratio for the output gear. So it's NG over DG, and that is 96 teeth divided by 8.0 inch. Now 96 divided by 8. What is this? 8 times 1. So it's 12, okay? 12 teeth per inch. So tell me, will this gear set operate smoothly? Yes or no? This condition is violated, okay? So it will not. The answer is not. You can't have 10 teeth per inch operate smoothly with 12 feet per inch. They will misalign. Now the next problem is 8.16. So this also looks scary because it's a long statement, but I don't think, I mean, if you break it down into smaller parts, things should be manageable. So now you are designing, so we have to translate this long list of requirements into equations or inequality or conditions. So you are designing a gear train with 3 spur gears. So one thing is clear, that you have 3 spur gears, okay? One input gear, so let's identify that by I for input. One output gear, O for output. I think because this is idler gear as well, so we should not say, maybe we just write 1, 2, 3. So let's call this 1, let's call this 2 idler gear, and let's call this 3. So 3 is our output gear, okay? So I have 3 gears. 1 is the input gear, 3 is the output gear, and 2 is the idler gear. You know, idler gear, we call it idler because it does not contribute to the calculation, because we have a simple gear train, okay? Simple gear train. Remember, this is tricky because the question does not say simple. Yeah, nowhere in the question it says simple. It simply says gear train. So this gear train could be simple or compound. Now, how do you figure out whether it's simple or compound? That hint is given by the idler gear. You have idler gear only in the simple gear train. In compound, there is no idler gear. Yeah. So that's actually, this is not a possibility. This is the only possibility. So we have to let me just remove all the annotations, and now I go back. This one input gear is 1. This is label that with 2 and label that with 3. Now the diametral pitch for the gear train is 16. Now what does this mean? That this must be true for all the gears, okay? So I can say that P diametral pitch, P1, P2, P3, they all must equal 16. And what is the unit of 16? Actually, because we are using US customary system here, so it has to be in teeth per inch, okay? Teeth per inch should be clear. You cannot use any other unit in this case. So the diameter of the input gear needs to be twice the diameter of the idler gear. Now, input gear is labeled 1. So what I am trying to say is that D1, okay, the diameter of the first gear, the input gear, must be twice the diameter of the idler gear, which is 2. This is one equation, okay? And it must also be, I'm not changing the line. So on the same line, that same D1 must also be 3 times the diameter of the output gear. So now it's 3 times D3, okay? And that's it. Now, if you want to make this calculation easy, I can give you a trick, okay? So think of a simple number. So D1, instead of D1, you can say, okay, you just introduce a dummy variable D, and you know the LCM of 2 and 3, 2 times 3 is 6, yeah? So if I say if D1 is 6D, 6 times D, D is any dummy diameter. So this will be D1, okay? This will be, so let's say D1 is 6D. Then D2 will be, tell me. D2 will be half of it. So it will be 3 times. 3 times D, yes, and D3 will be 1/3 of it, yeah, so it will be 2 times D. So I have a dummy diameter D so that the input gear has diameter 6 times D, the idler gear has diameter 3 times D, and the output gear has diameter 2 times D. Now, what is the advantage of introducing this intermediate D? You will see it in a while, okay? Dealing with this equation may not be so easy. So now, look for more requirements. The entire gear train needs to fit into a rectangular footprint of no larger than 16-inch high, okay? So now you have a requirement that the height must be within 16 inch. You cannot have, these gears must fit into an area, a vertical area, with height no more than 16 inch. And this length must not be more than 24 inch. So if you have these gears somewhere in the middle, all the 3 gears must fit so that, so which means that the largest diameter must be less than 16 inch, and the sum of all diameters, because they must fit in horizontally as well, so the sum of all diameters must be less than 24. So let me just write it down for you. The largest diameter must be less than 16 inch, and the sum of the diameters, sum of dias, must be less than 24. Now, what is the largest diameter? The largest diameter is D1, or more conveniently 6D. So 6 times D must be less than 16 inch, okay? You can remove this for clarity. Now, what is the sum of diameters? Now you will see the advantage of that. 6D plus 3D plus 2D, so it is 11D. Yeah. Now, if you had not chosen this intermediate variable, you would have written D1 plus 2D, D2 plus D3, and it would have taken longer. Okay. So you must actually satisfy both these constraints. Now it should be easy. Now choose D, tell me, choose some value of D, because the question is determine an appropriate number of teeth and diameter of each gear, okay? So first we need to choose the diameter. So if I choose D, I can choose all the 3 diameters because that D is appearing in every expression. So let me choose D such that both these conditions are respected. So can you suggest a value? We need to go for a simple value because that will be translated to the number of teeth as well. So don't go for fractions, okay? Fractions may complicate things. So how about a value of 2 inch? Why is a value of 2 inch reasonable? Because you check this, 11 times 2 inch is 22 inch. 22 inch is less than 24 inch. So that is satisfied. Look for this. 6 times 2 inch is 12 inch, and 12 inch is less than 16 inch. So both the conditions are satisfied. You can come up with any other value, but this is simpler. Now once you choose D to be 2 inch, now I can go back. This D1 must be 6 times 2 inch, yeah, which is 12 inch. D2 must be 3 times 2 inch, which is 6 inch. And D3 must be 2 times 2 inch, which is 4 inch. So I have all the 3 diameters. And I can now convert all these three diameters to the number of teeth. How? Because for all of them, this pitch must be the same, which is the number of teeth divided by the diameter, which means that the number of teeth in all cases must be equal to, let's call this P, yeah? It must be equal to P times D, yeah? So 16 times 12, 16 times 12 is the number of teeth for the first one. 16 times 6 is the number of teeth for the second one, and 16 times 4 is the number of teeth for the third one. Yeah. So the question looked very complicated, but if you understand the meaning of these diametral pitch, yeah, and how to translate these word statements into inequalities, mathematical equalities, and just remember that these two are basically only one of them includes the other. So it looks like 11D less than 24 already includes that. Okay, so that was it. You can even work it this way. So if you solve this one, it is D less than 24 over 11 inch, and this D less than 16 over 6 inch. So these two values can be compared, and then one of these inequalities will automatically include the other as a special case. Okay, let's move on to the next question. And this is a rack and pinion arrangement, which is motorized. So the pinion gear is driven by a motor. So you have motorized rack and pinion system. This is pinion, this is rack, as you already know, in a milling machine. The pinion has 50 teeth, okay? So I can say that, okay, NP is 50. And a pitch radius of 0.75 inches. So I can write this down here, okay? NP is 50 and RP, pitch radius, is 0.75 inches. Over a certain range of its motion, the motor runs 800 RPM given. That's 800 RPM is given. So that is basically your omega of the motor. You can call it omega motor or just call it omega if you don't need omega elsewhere. So determine the horizontal velocity of the rack. Okay, so we want to find the horizontal velocity of the rack, V. Now remember, this pinion gear must mesh with this rack. Okay, so because they are both compatible by assumption, so there must be no slippage, no sliding. Yeah, the operation must be smooth, which means that they cannot have different velocities. So this same V must be the linear velocity of the pinion gear, yeah, as well as you see it's the same V. So this V must be the velocity for the pinion as well as for the rack, yeah, because otherwise they are not compatible. So which means that V can be related to we can now just apply R times omega. Yeah, we know that this is a circle. We can now forget about the rack. Okay, but we just need a connection that the horizontal velocity of the rack is equal to the linear velocity of the pinion, and that allows us to use this equation. This equation is true for the pinion, but we know the pinion and rack, they must move together. So I can now simply plug these values. It's RP omega p, and I'm not writing Vp because that V is the same. Okay, so V is equal to Vp as well as V rack. So I simply write 0.7 inch times omega p is 800, and I'm not writing, yeah, I can simply say omega p, because this is for the pinion. Although that omega was for the motor, but the motor and pinion, they must run together, okay? So omega p is actually equal to omega pinion, omega motor. So it's 800 RPM, yeah? And you need some factors so that this gives you inch per second, okay? Inch per second. You have to get rid of revolution, you have to get rid of minutes, so that you have seconds here and you have inches here. That the first part was easy. Second part, if a peak torque of 10 foot-pound is supplied by the motor, it's also indicated here, okay? So that is your peak torque, T. So that T is provided by the motor, but I can also say TP because that is the torque applied to the pinion. Determine the pulling force that is produced in the rack and transferred to the milling machine. Now, just like part A, because here they must mesh, so the force, the linear force at the mesh must be the same. So the same force must be for the pinion as well as for the rack, yeah, because when they mesh, what must be compatible is the linear motion, क्योंकि इस टाइम पे कोई रोटेशन नहीं हो रही है, इस टाइम पे जो ट्रांसलेशन हो रही है वो दोनों के लिए सेम है. So it's, we can call it F if you want, okay? So that F must be torque divided by the radius, okay? TP divided by RP. We know T is F times R, so that is easy. So it's 10 times 10 foot-pound divided by 0.75 inches. Of course, you need to have these factors so that feet and inch are dealt with, and you will have your answer in pounds, okay? Easy. The trick was, this was the trick. Let me just highlight the trick. The trick was this. And the first part, the trick was this. If you miss out these two rules, and they are actually a mathematical way of saying running or operating smoothly. You don't want a mechanism which doesn't run smoothly. So that smoothness translates to this equation and to this equation. Actually, both are equally important. You cannot have this equality of velocity if you don't have an equality of forces, okay? Okay, the next one. So we now move on to the next topic. And so far in this chapter, we have only discussed, actually remember this chapter is about transmission of motion, and of course power, because you cannot have motion without power. So for that transmission of motion, we have only considered gears so far in this chapter. Of course, in the other book we have also discussed pulleys and levers, yeah, and screw jacks, things like that. But in this book and in this chapter, we have been focusing on gears. Now, gears are desirable because they have synchronous rotation. Yeah? Just like I said, that Vp and Vg, the requirement of Vp equal to Vg and Fp equal to Fg. This is just another way of saying that you must have synchronized motion. Yeah, they must be synchronized. Now, but sometimes that's not all you need. Okay, you also need some flexibility. That okay, if one shaft is here, remember this shaft is into or out of the page, and one shaft is here into or out of the page. What if you want to, for some reason, if you want to have these two shafts at a large distance, Yeah, so you definitely need some other mechanism. Yeah, you cannot have gears, because gears, they must actually touch each other. So here you need something which is called a belt. In one case it's a belt, and in another case it's called a chain. Okay, but let's start with belt drives. We use the word belt if there is some kind of flexibility. So flexibility is the key. Yeah, now these belts, they must be manufactured from materials so that they are flexible, and this way they allow us to isolate two shafts. So they are isolated now. Okay, maybe one is in a dangerous place and the other is in a place near to humans, so you would like to isolate them, or maybe there may be and you need long distances. So these two properties require some degree of flexibility. Now when you have a flexible belt, okay, but flexibility doesn't mean that it should be very loose. It should also be tightly grooved to the pulley. So you need, if you zoom the pulley must have this V shape, okay, so that the belt actually fits in and it doesn't actually move. So that's why the majority of belts are called V belts, and they have this special wedge shaped, and you make them from reinforced rubber. Okay, why reinforced? Because if you only make them from rubber, of course rubber is flexible, okay, they will be flexible, but they will not be strong. Yeah, they will not be, modulus of elasticity E. So to increase stiffness, you reinforce that rubber with some, for example, plastic, or I forgot the name, but there are some materials which you must add to rubber to increase the modulus of elasticity. Plastic, or I forgot the name. I think you should read it. It's given in the book. So you need strength as well as flexibility. Okay, it should not be flexible like rubber. It should be nearly flexible, but it should also be strong. So because this V belt must fit into the pulley must also be made in a special way, and that's why it's called sheave. So if a pulley is grooved, yeah, so that you have this groove in it, so that the uh, the belt fits in, you call it a sheave. So a sheave is just a fancy name for grooved pulley. Okay, so remember, you need V belt, and it must fit in what is called a sheave, and sheave is just another name for groove pulley. Okay, so because of flexibility, you will have some slippage. They will slip past one another, but you can't avoid that. But if that slippage can be neglected, yeah, if it's not too much, then you can assume synchronous motion, just like gears. So although you don't have gears, they are separated, they are isolated at long distances, but you still can assume that synchronous motion, just like gears. So the mathematical equations will be the same for gears and belt drives if you ignore slippage. Okay, and this is what we'll do for problem solving. The error will not be that significant. Now, of course, there are some applications where this shape, the V belt, is not desirable. Okay, you need because you need to have isolation just like before, long distances just like before, but you need exactly synchronous motion. Here it is nearly synchronous. So for V belt, I can say it's nearly synchronous because I'm ignoring slippage. If you want slippage to be not a possibility or extremely negligible, then you need what is called a timing belt. Yeah. So in a timing belt, you have this belt, but you make it so that it looks like a gear. Okay. So you have the, I can also call it a tooth belt, tooth belt. Okay. So you make the belt not only of reinforced rubber, but you also make it so that it has the desired properties of gears as well. Now the speciality of gears is synchronous motion. The speciality of belts is isolation and long distances. And when you have a timing belt, you have actually both these properties. You have the best of the two worlds. So you have a property of gears as well as a property of belts. And that's why in more serious applications, you will see timing belts and they look like that. Okay? Um, if you open a hard disk or any miniaturized application, you will see these timing belts. इसमें कोई question है before I move on to the next topic? Although we have this timing belt, but remember it is still a belt. Okay, so this may not solve all the problems. Sometimes you need, because the problem here will be, okay, you do get this desirable property, synchronous motion, but it may not be strong enough. If you need strength, क्योंकि गियर्स की दो प्रॉपर्टीज है ना, गियर्स की एक प्रॉपर्टी है सिंक्रोनस मोशन, उसकी दूसरी प्रॉपर्टी क्या है? दे आर स्ट्रॉन्ग, they can carry long, actually they can withstand long stresses, large stresses. So for that you have to replace belt drives with chain drives. Now chains जिस तरह बाइक में आपने देखे होंगे वो मेटालिक होते हैं. अब मेटालिक का ये है कि you automatically have these properties. Okay, long distance may not be actually, I mean it's just short distance, but you do have oscillation, you do have synchronous motion, but you have added, so okay, synchronous motion and slippage can be neglected, but they are used when you need high torque, okay, sorry for this typo, and high power, and that's why it must withstand large forces and large temperatures. Now that is not something you can achieve with belts, because belts are made from rubber, and even if you reinforce the rubber you will still have problems. Okay, even those teeth cannot solve the problem, so you just replace that with metals. Of course metals don't allow you long distances, but they have all the other desirable properties. Anyway, whether you are dealing with belts or chain drives, if you ignore slippage you can assume synchronous motion. And when you assume synchronous motion, you have all the properties of gears. Gears की property क्या थी? कि the linear translational velocity, the linear velocity must be equal to, for the pinion must be equal to that for the gear, and same for the force. Okay, force must be equal to force gear. Now we can use the same assumption or approximation for belts and chain drives when we ignore slippage. So that we will use for problem solving. So we will now solve a few examples, and you will see how that equation. So you use the same equation as you used for gears because you are ignoring slippage. So now let's start with this example. You have a mechanism and a desktop computer scanner. So this is the scanning head. You have a motor. You cannot have a scanner without a motor. And this motor is located here, the scanner is located here, and you need to isolate them. Okay, so that's why you need this chain or belt. It doesn't matter because we can still use the same, it turns out to be a timing belt. Okay, and you see that, okay, the gear connected to the motor, the pinion gear, it has 20 teeth, and the output gear is 80 teeth. Okay, and that gear is connected to a shaft which is called a transfer shaft, and on that transfer shaft you not only have this output gear but also another gear. Yeah, and that gear is then connected to the timing belt. Okay, and that timing belt is then connected to a pulley. Actually this is a pulley, this is not a gear, sorry, this is a pulley. This is a pulley, and remember what was the name given to these pulleys? They were called sheaves. Yeah, let me know. sheave. Okay, sheave. Just like this special type of pulley they were called sheaves. For chain belts, the structure which plays the role of a pulley, you don't call it a pulley, you call it a sprocket. Okay, remember. So the sheave is replaced by what you call a sprocket. Now, so let me explain this again. You have a motor. That motor is connected to a pinion gear. That pinion gear meshes with an output gear. The transfer shaft on which you have this output gear, you also have a groove pulley and another groove pulley, and they are isolated by what you call a timing belt. Okay. Now this mechanism converts the rotation of a motor's shaft into the side-to-side motion of the scanning head. So मोटर की जो रोटेशन है वो इसको linear motion में to and from motion में इसको convert कर रही है. During a portion of a scan operation, the drive motor runs at 180 rpm. So एक तो ये बात हो गई कि जो ओमेगा है वो है 180 rpm. And because this, you can say omega of the motor, but you can also say omega of the pinion gear, because this is your pinion gear that is connected to the motor. And you also know that for that pinion gear, you have NP equals to 20. Okay. Now, the gear attached to the motor's shaft has 20 teeth. So that we already did the pinion gear. And the timing belt has 20 teeth per inch. ये लिखा हुआ है इधर 20 teeth per inch. Okay. This represents the proximity. Okay, timing belt में ये जो teeth है ये कितने closed है, how close they are. 20 teeth per inch should tell you how close they are. The other two gears are sized as indicated. तो बाकियों के लिए आपने क्या नोट किया कि you have 80 teeth. So this 80 teeth and G is for the output gear. This is the output gear. Okay. And omega G, which you can calculate, it's not given. Okay. The two other gears. Okay. The two other gears. So I'm just now thinking. Okay, so it looks like if you look at this timing belt, now I understand the question. Okay, when we were studying the belt drives, okay, so we only had pulleys here. Yeah, we only had pulleys and we were not showing motors here. Okay. Of course, if this pulley is to be driven by a motor, this shaft must also be connected to a gear. Okay. So this means that in this question, you have another gear here. Okay. So this timing belt must be connected to another gear, and the number of teeth for that is 30 teeth. Okay. So you have 30 teeth here, and you have 80 teeth here, and maybe we should not label them like that. We just remember it from the diagram. In units of inch per second, calculate the speed at which the scanning head moves. Okay, so this is our goal. We need to calculate the speed at which the scanning head moves. So let's call that speed V. V is the speed. Okay, now this Let me just actually declutter it, because I don't need all these comments now. Now, the only way to attack this question, or such a complicated question, is to make sure what assumptions you need. Yeah, assumptions are important, okay, because they are part of the strategy. So these two gears, they must operate smoothly. We already know that. And this timing belt must operate smoothly with this gear, okay, and of course with this pulley. So now we should focus on this gear, which has 30 teeth. So 30 teeth of this gear, they are in one revolution, okay? 30 teeth, they are in one revolution. Yeah, because if you have two revolutions, you have to multiply this 30 by 2. Now, in this one revolution, because it has to operate smoothly with the belt, the timing belt must also mesh 30 teeth, okay? So I can say that one revolution of the 30 teeth gear will give me 30 teeth of the timing belt as well. Yeah, because they must run smoothly. Yeah. Now one revolution का मतलब ये है कि आपने कोई डिस्टेंस कवर किया है सर्कल में. अब ये सर्कल वाला डिस्टेंस तो गियर का है ना, टाइमिंग बेल्ट ने तो उस मोशन को ट्रांसलेट करना है लिनियर मोशन में. तो इसका मतलब ये है कि दिस horizontal distance covered by the timing belt, this distance in one revolution, remember important है कि सिर्फ एक revolution में, वो कितना है? Let's call that, we use x for the distance, and because x is used for any distance, I just call it x divided by theta, because we can use theta for revolution. Yeah, because one revolution will have some radians, okay, so I can say x over theta. Okay, the distance covered per some angle, that will be equal to 30. No, the distance is, you know, and if you now look at this 20 teeth per inch, that 20 teeth per inch gives me something. I cannot write 20 teeth. I have to write 1 inch divided by 20 teeth. Are you getting me? Because 1 inch horizontal distance is covered by 20 teeth. Now I need to multiply this, because this is going on in one revolution. So I know in one revolution, I can multiply this with a factor which is one revolution. This is just like unit conversion. And I need to get rid of the teeth. In one revolution, how many teeth? 30 teeth. So you see the trick. I'm using the trick of units here. 1 inch per 20 teeth is the information I picked from there, because this is how much distance the timing belt covers. So for 20 teeth, it covers 1 inch. For 30 teeth, it covers one revolution on the gear. So I place this 30 teeth and this one revolution in such a way that this is 1, and now I can get rid of this teeth and this teeth, and I get my x over theta. This theta is just an angle, remember. So by that angle can be 1 radian, it can be anything. When you divide it, it disappears, okay? So now, how does this help me calculate the velocity? So now I will be using this piece of information. I need velocity, horizontal velocity of the timing belt. Now I know horizontal velocity can be, I also know that because they must okay, one more thing. Now this angular velocity will be important. Now this gear of this 30 teeth gear, this is mounted on the same shaft as the 80 teeth gear, okay? And they are both on the transfer shaft, okay? So I can say that, okay, the angular velocity of that, I mean, maybe I should not call it omega g, I can call it omega t for the transfer, okay? Because transfer shaft पे ये वाला gear भी है, उसी transfer shaft पे ये 30 teeth वाला भी है. So I can now convert between these two, between omega p and omega t, and for that I can simply use the assumption that they are synchronous. पिछले slide वाला. So it is omega p, और यहाँ पे मुझे पता है कि np आएगा और यहाँ पे ng आएगा. Okay, so I can now plug this values. np की वैल्यू ये आ जाएगी 20, इधर आ जाएगी. ng की वैल्यू यहाँ पे आ जाएगी. ओमेगा p की वैल्यू ये आ जाएगी. And this will give me omega t in rpm, revolutions per minute. Now that same omega t must be true for the 30 teeth gear. Okay. Now I can combine all these pieces of information. मुझे linear velocity चाहिए. Linear velocity x over theta मुझे पता है, x over 3. But x over theta is not equal to linear velocity. Okay, I can multiply this with theta over t. अब ये equation कहाँ से आया है? Okay, if you get scared of this equation, I can simply use the definition. It is dx over dt, linear velocity. I can apply chain rule. So dx over d theta. Theta represents the angle of rotation, which can be 2 pi radian as well, and d theta over dt. And because the speeds are constant here, I can simply say x over theta and theta over t. Okay, I don't need the derivative because everything is constant motion. So x over theta I know from here, so this value will come here. Now you see the strategy, okay? And theta over t क्या है? Theta over t is your omega t, yeah? Because omega t is d theta. You can call it d theta over t or theta over t. जब constant है तो वो theta over t भी आप उसको कह सकते हैं. So this is how you combine these different pieces of information. Trick मैं इसमें explain कर दूं. इसमें वही trick था कि you have to recognize two things here. You have to recognize the synchronous motion of these two, the 20 teeth gear and the 80 teeth gear. Synchronous motion का मतलब सिर्फ ये है कि mesh पे उसकी linear velocity same है. लेकिन जो time transfer shaft पे जो दो gears हैं, ये 80 teeth वाला और 30 teeth वाला, they must have the same angular velocity as well because they are on the same shaft. So that's why we are labeling it as that angular velocity as omega t and not omega g, because we know that same angular velocity will be the reason for this timing belt, and we multiply that with something we derived from this 20 teeth per inch, because 20 teeth per inch tells me how to convert teeth, the number of teeth, to inches. So x over theta tells me how do I convert rotations to distances, and then I combine these two. Okay, ये बुक में भी सॉल्व हुआ है. बुक में वो एक गलती करता है कि वो इसको x कह देता है. So बुक का जो मसला है वो इस क्वांटिटी को x कहता है, which is mathematically correct क्योंकि theta is dimensionless, सिर्फ x का यूनिट है. लेकिन ये है कि conceptually it may confuse you. So ये x over theta और theta over t वाला पिक्चर जो है ना, ये ज्यादा क्लियर है मेंटली. मतलब अगर डायमेंशंस को आप इग्नोर करते हैं तो फिर आप टीथ भी लिखना बंद करते हैं. हम टीथ क्यों लिखते हैं? हम रेडियन क्यों लिखते हैं? रेडियन पर सेकंड अगर आप रेडियन ना भी लिखे मैथमेटिकली स्टिल ओके, 1 over second इज द सेम एज रेडियन पर सेकंड. लेकिन हम रेडियन टीथ इसलिए लिखते हैं कि वो कंसेप्चुअली हमें हेल्प करता है प्रॉब्लम को सॉल्व करने में. So try to put as much explanation as possible when you're solving a problem. उसका फायदा ये होगा कि आप अगर कंफ्यूज भी हो जाएंगे तो वो चीजें आपको नजर आ रही होंगी, ठीक है। सो जस्ट करेक्टनेस इज नॉट इनफ। गलती आप तब करते हैं जब आप कहते हैं टेक्निकली ठीक है, टेक्निकली ठीक इनफ नहीं है। इट शुड बी रिवीलिंग, व्हाट यू राइट मस्ट बी रिवीलिंग सो दैट इट हेल्प्स यू इन द प्रॉब्लम सॉल्विंग। अगर आप सिर्फ ठीक लिखेंगे तो ठीक आपको आगे ले जाने में हेल्प नहीं करेगा फिर। The next question is you again have a timing belt, okay, and that is used to transfer power in the exercise treadmill. The exercise treadmill आपका, इस पे somebody has to walk on it, and this is mounted on a roller, okay, from the motor to the roller that supports walking running belt. The pitch diameters of the sheaves, sheave आपको पता है वो special pulley होती है, tooth pulley, on the two shafts. एक ये shaft है, इस पे ये sheave लगी हुई है, ये जो tooth pulley है, और एक ये shaft है, इस पे भी लगी हुई है. So they have diameters of 1 inch and 2.9 inches, okay. So these two will now help us convert the angular velocities from one shaft to the other. Because they are separate shafts, so their angular velocities they don't need to match. Only their linear velocities needs to match. They need to match. And the roller has a diameter of 1.75 inch. Roller का अपना जो diameter है वो 7.5 inch है, ठीक है. So three different diameters. Diameter of this shaft. Diameter of this pulley, diameter of this pulley, and diameter of that pulley. अच्छा, वो जो हम कैलकुलेशन करते हैं ना एंगुलर वेलोसिटीज को ट्रांसफर करने के लिए, तो उसमें यहाँ पे एक चीज शायद मैं एक्सप्लेन नहीं किया था मैंने, और वो इसलिए मुझे मौका नहीं मिला कि इस क्वेश्चन में डायमीटर गिवन ही नहीं था, इसमें डायमीटर नहीं गिवन था, ठीक है. वजह क्योंकि यहाँ पे ऑल्दो द पुली वाज हियर बट देयर वाज अ गियर एज वेल, और उस गियर के जो है ना टीथ आपको मिले हुए थे, तो आपने बेसिकली गियर वाला इक्वेशन ही यूज किया है, ओके. So that means that we need to go back and try to understand, or maybe I can explain it here. So let's say I am explaining something which is needed for this example, but this is not, I mean, we are not discussing the example, we are discussing something else. Timing belt या chain में you have pulleys, and these pulleys can have different diameters. So let's say D1 and D2, okay, and they can have different angular speeds. So इसका जो angular speed है वो omega 1 है और इसका angular speed क्या है, omega 2 है. Because they must operate smoothly, so what must be common? ये जो belt का जो linear velocity है ना, वही linear velocity इसका भी होना चाहिए और वही linear velocity इसका भी होना चाहिए. So the same velocity must be, which means that omega 1 d1 must equal omega 2 d2. This will be your equation for synchronous motion. यहाँ पे you will not see the number of gears because ये teeth का equation नहीं है. जब आप gears के लिए equation लिखते हैं तो you have a relationship in terms of ng and np. आपको याद होगा omega 2 omega 1, और यहाँ पे आप लिखते हैं n1 over n2. यहाँ पे n1 n2 का चक्कर नहीं है क्योंकि पुलीज है, पुलीज में टीथ नहीं होती, पुली में जो है ना उसका डायमीटर होता है. So that is something we need to keep in mind for this question. क्योंकि इसमें कोई नंबर ऑफ गियर्स हमें नहीं दिया हुआ, नंबर ऑफ टीथ हमें गियर्स पे नहीं दिया हुआ. So now how do I first let's find out what is required for a running pace of 7 minutes per mile. Okay, at what speed should the motor be set? Express your answer in units of RPM. Okay, interestingly जो मोटर का RPM है वो क्या होना चाहिए कि आपको 7 मिनट पर माइल मिल जाए। अच्छा, अब यहाँ पे अगेन वी विल अस्यूम सिंक्रोनस मोशन। सिंक्रोनस मोशन का मतलब ये है कि अगर आप एक तरफ आपका रोलर है और एक तरफ आपका मोटर है, बीच में ये जितना भी स्टफ लगा हुआ है, इन सब की लिनियर वेलोसिटी सेम होनी चाहिए। व्हिच मींस कि जो रोलर की लिनियर वेलोसिटी है v, लिनियर वेलोसिटी क्या हो जाएगी, आई नीड टू कन्वर्ट दिस क्वांटिटी। ऑल्दो इसको ये पेस कह रहा है, लेकिन ये लेमेल टर्म है। वेलोसिटी मिनट पर माइल नहीं होता, माइल पर मिनट होता है। so इसका मतलब ये है कि द वेलोसिटी ऑफ द person is 1 mile per 7 minute. ठीक है, just because you are given 7 minutes per mile doesn't make it a velocity. The velocity is 1 mile per 7 minute. This you need to multiply with some factor so that you get inch per second. Inch per second. बल्कि inch per second, because we need RPM. So maybe you can even write this as inch per minute. That may simplify your calculation. आपको ultimately RPM चाहिए ना, तो inch per minute is good enough. Ultimately आपने उसको per minute में फिर भी convert करना. Now that velocity must be true for this second gear as well. जिसका 22.9 इंच वाला है, इसकी वेलोसिटी भी इतनी होनी चाहिए, रोलर की भी इतनी होनी चाहिए, और 1 इंच वाली भी इतनी होनी चाहिए. Now जो इसकी एंगुलर वेलोसिटी है रोलर की जो एंगुलर वेलोसिटी है वो कितनी है? That you can, so you can divide v over r. Okay, ये वैल्यू यहां से आ गई इंच पर मिनट में, और रेडियस आपका रोलर का दिया हुआ है 1.75 inches. Okay, now that angular velocity, now you have these two gears, और इनके दरमियान जो एंगुलर वेलोसिटी का रेशो है, वहां पे आप ये वाला इक्वेशन जो अभी मैंने किया था कि ω1 d1 must equal to ω2 d2, you can convert between the angular velocity of the motor and the angular velocity of this 2.9 inch gear by this equation. ठीक है, अब क्वेश्चन ये है कि 2.9 इंच वाली जो एंगुलर वेलोसिटी है उसको आप रोलर की एंगुलर वेलोसिटी के साथ कैसे मैच करते हैं. ठीक है, तो उसमें भी आपको रेशोस पता है. देखो ना, जिस तरह इन दो का पता है d1 d2, सो यहाँ पे एक 1.0 इंच है और दूसरा क्या है 2.9 इंच. इसी तरह जो 2.9 इंच वाला रोलर के साथ जो है, रोलर का डायमीटर भी आपको पता है, इसका है 2 times r, which is 2 times 1.75 inch. So you can use the same kind of equation, omega roll times d roll equals both of these, so that you can actually use to so you started with linear velocity. From this piece of information, you converted that linear velocity to some angular velocity, and using this synchronous motion, you convert one angular velocity to the next to the next. और आपने रुकना किधर है? जब आप उस शाफ्ट पे पहुंच जाएं 1 इंच वाले गियर पे जो मोटर के साथ कनेक्टेड है, क्योंकि जो मोटर की एंगुलर वेलोसिटी है वो आपको पता, वो आपको रिक्वायर्ड है. मोटर एंगुलर वेलोसिटी इस गियर की वेलोसिटी है, ठीक है, इस गियर की नहीं, सॉरी, इस पुली की, इस पुली की। ये टाइमिंग, ये टाइमिंग बेल्ट ये हुआ, ये एक पुली है, ये दूसरी पुली है। इन दो पुली के दरमियान जो ट्रांसफॉर्मेशन है वो इस इक्वेशन से आ जाएगी। ठीक है, और यहाँ पे ट्रिक ये है कि मुझे वो दूसरी ट्रांसफॉर्मेशन करनी नहीं है। इसी शाफ्ट पे ये 2.9 इंच वाला भी है और रोलर भी है। सो इसका मतलब ये है कि दोनों इक्वल हो जाएंगे। ये ट्रांसफॉर्मेशन मुझे सिर्फ एक दफा चाहिए, यहाँ नहीं चाहिए। आई डोंट नीड दिस ट्रांसफॉर्मेशन। ओके, क्योंकि जो 2.9 इंच की एंगुलर वेलोसिटी है वही एंगुलर वेलोसिटी आपके आपके रोलर की भी है। ठीक है, सो विच मीन्स दैट this angular velocity of the roller, which is v over r, that omega roll is also equal to, let's label this as 1 and let's label this as 2 for simplicity. So I say 1, 2 and roll. Okay, so omega roll is equal to omega 2. No transformation needed because they are both on the same shaft. Yeah, and from, so omega 1 तो मुझे कैलकुलेट करना ही नहीं है। अब ओमेगा 1 से मुझे क्या चाहिए, ओमेगा 2 से मुझे क्या चाहिए, ओमेगा 1, क्योंकि ओमेगा 1 इज इक्वल टू ओमेगा मोटर, वो मोटर के साथ लगा हुआ है। अब यहां पे मुझे चाहिए ओमेगा 2 से ट्रांसलेशन, which is d2 and d1. Yeah, so I need this transformation only once. Okay, बाकी ये बुक में सॉल्व होगा। कोई क्वेश्चन था?
सर मैं कह रहा हूँ हमारी नेक्स्ट क्लास स्टार्ट होगी।
ठीक ठीक, ओके, थैंक यू। बस आप पे लगा दें।